There is something quietly remarkable about being human. For as long as anyone can remember, we have looked upward. Long before telescopes, before observatories, before we understood what stars truly were, there were people sitting beside campfires, beneath the night sky, wondering if those distant lights could ever be reached. Tonight, perhaps you can imagine joining them for a moment. There is no city around us, no sound, except a gentle wind moving through the darkness. Above us stretches a sky so vast that it almost feels impossible to hold in a single glance. Thousands of stars rest silently overhead, each one appearing close enough to touch, despite being separated from us by distances the human mind was never designed to comprehend. And yet, almost immediately, a question appears. What is out there? It may be one of the oldest questions our species has ever asked. Civilizations, separated by oceans and centuries, gave different names to the lights above them, but they all shared something in common. They imagined crossing the distance between here and there. The ancient Greeks placed gods among the stars. Polynesian navigators trusted them to cross entire oceans. Poets wrote about them. Philosophers built ideas around them. And, eventually, scientists began to measure them. But long before we possessed answers, we possessed curiosity. Perhaps that is why the universe has always felt less like a place and more like an invitation. It is difficult to say when humanity first dreamed of traveling among the stars, because in many ways, we never stopped dreaming. Every generation simply inherited the question from the one before it. Could we ever go there? For most of human history, the stars appeared fixed and eternal. Small points of light painted onto a great celestial sphere surrounding the Earth. Beautiful, distant, and somehow comforting in their consistency. Then, slowly, we began to discover something extraordinary. The stars were not nearby at all. They were suns. Entire worlds might orbit them, and the nearest among them was separated from us by distances so immense that ordinary words became useless. Kilometers were no longer enough. Even years, something that once felt unimaginably long to a human life, suddenly became a unit of distance. And at the center of this realization stood something we encounter every day without a second thought: light. For most of history, people did not know whether light traveled at all. It simply seemed to exist. You opened your eyes, and there it was. But in time, careful observations revealed something astonishing. Light has a speed. It does not arrive instantly. Every sunrise you have ever seen took a little more than 8 minutes to reach Earth. The moon you might glimpse through a window tonight appears as it was just over a second ago. Even the nearest star beyond our sun sends us light that began its journey more than 4 years in the past. In a quiet sense, looking into the night sky is not a matter of distance. It is a matter of time. The universe we see has already happened. And perhaps that is why the stars feel so mysterious. They are not merely far away. They are messages. Silent ones. Messages that have spent years, centuries, and sometimes billions of years traveling across the darkness to arrive here, in this moment. As you listen to a voice speaking softly in the night, there is something comforting about that thought. Some of the light reaching Earth tonight began its journey before humanity existed, before there were cities, before there were languages, before our ancestors learned to shape tools from stone. And somehow, after crossing an expanding universe for unimaginable stretches of time, it arrived exactly where it needed to be. In your eyes, as our understanding grew, so did our ambitions. Writers began imagining impossible machines capable of crossing the stars. Scientists wondered whether nature had hidden shortcuts among the laws of physics. Entire generations grew up believing that one day humanity would leave Earth behind and become a species of travelers. The 20th century gave these dreams new forms. Towering rockets, silver spacecraft, stories of distant civilizations. From the pages of science fiction to the earliest steps upon the moon, humanity became increasingly convinced that the stars were not merely something to admire, they were destinations. There is a certain inevitability to this. Curious creatures do not remain still forever. A species that learned to cross rivers eventually crossed oceans. A species that crossed oceans eventually reached the moon. It seems only natural that, one day, we would turn our attention toward the spaces between the stars. And so, generation after generation, we have continued asking the same question. If we can build better engines, if we can gather enough energy, if we can simply continue accelerating, could we travel forever? Could we continue gaining speed until, at last, we caught up with the very thing that carries the stories of the universe itself? For a long time, that question seemed perfectly reasonable. After all, in everyday life, faster is simply faster. A bicycle becomes a car becomes an airplane becomes a rocket, and somewhere, hidden within that simple progression, humanity quietly assumed there was no final step. That if we were patient enough, clever enough, determined enough, we would eventually discover that the universe had no speed limit at all. But the universe, as we would eventually learn, had been keeping a secret, and like many of its secrets, it would reveal itself not through force, but through light. For most of our lives, speed feels simple. A child learns it instinctively. Walk a little faster, and you arrive sooner. Ride a bicycle down a quiet street, and the world begins to blur at the edges. Sit beside the window of a train, and distant hills seem to drift slowly, while nearby trees rush past in a green whisper. Everything around us teaches the same lesson. Motion is relative, but time remains unchanged. Or so it seems. The universe is kind enough to let us spend our entire lives without questioning this arrangement. On Earth, our days pass at a comfortable pace. Seconds feel like seconds. Hours feel like hours. Cause follows effect with reassuring consistency. Nothing in ordinary life prepares us for what happens when we begin approaching the speed of light. In fact, if someone had tried to explain it to an astronomer 200 years ago, they might have assumed it was a philosophical puzzle rather than a description of reality. Because the deeper we looked, the stranger the universe became. By the 19th century, scientists had become increasingly fascinated by light. They had learned that it behaved like a wave, and every wave, it seemed, required something to travel through. Sound moves through air. Ocean waves move through water. Surely light, too, must have its own invisible ocean. They gave this unseen substance a beautiful name: the luminiferous ether. According to the best ideas of the time, the entire universe was submerged within it. Stars floated through it. Planets drifted through it. Even Earth, moving silently around the sun, was thought to be cutting through this cosmic sea every moment of every day. It was an elegant idea. And like many elegant ideas in science, it turned out to be wrong. In 1887, two physicists, Albert Michelson and Edward Morley, built an extraordinarily delicate experiment. Their goal was simple: detect Earth's motion through the ether. If our planet was truly moving through this invisible medium, then light traveling in one direction should move slightly differently from light traveling in another. The difference would be tiny, but it should be there. Night after night, measurement after measurement, they searched for it. And the universe answered with silence. No matter how carefully they looked, the result remained the same: nothing. There was no sign of the ether. It was as though light had no need for a cosmic ocean at all. For a time, scientists wondered if the experiment was flawed. Others proposed increasingly complicated explanations. But sometimes, the simplest answer is also the most unsettling. Perhaps there was no ether. Perhaps light was obeying rules unlike anything else in nature. It is difficult to appreciate just how strange this realization was. Imagine throwing a ball while standing on a moving train. To someone beside you, the ball travels at one speed. To someone watching from outside, its speed changes because the train itself is moving. This is how the world works. Or at least, it is how we expect it to work. But light refuses to participate in this arrangement. No matter how fast you move, no matter where you are in the universe, light behaves as though it has made a decision long before you arrived. Its speed remains the same. For everyone, it is one of the most extraordinary facts ever discovered. A person standing still and another traveling at tremendous speed will disagree about many things: distances, durations, even the order of certain events. But they will agree on this: light moves at exactly the same speed, always. Somewhere in the early years of the 20th century, a young patent clerk in Switzerland became captivated by this mystery. His name, of course, was Albert Einstein. There is a story often told about him, one that feels particularly appropriate on a quiet night like this. As a teenager, Einstein imagined what it would be like to run beside a beam of light. If he could somehow keep pace with it, what would he see? Would the light appear frozen beside him, like a wave suspended in space? The question lingered in his mind for years, and eventually he arrived at a remarkable conclusion. The problem was not with light. The problem was with us. Space itself would have to change. Time itself would have to change. Because if the speed of light remains constant for every observer, then reality cannot be as fixed as we once believed. In 1905, Einstein introduced what we now call special relativity. It is difficult to overstate how profoundly this changed our understanding of the cosmos. Until then, Space had been considered a stage upon which the universe performed its endless play. Time was a separate thing altogether, flowing steadily and identically for everyone. Einstein suggested something different. Space and time were not separate actors. They were threads woven together into a single fabric, space-time. And suddenly, questions that had seemed impossible began to acquire answers. Why does light always move at the same speed? Because space and time adjust themselves to ensure that it does. Why can we never simply add our speed to the speed of light? Because the universe refuses to allow it. It is almost as though reality has written one law more deeply than all the others. A law that existed long before stars formed, long before planets cooled, long before anyone looked upward and wondered what lay beyond the darkness. There is a temptation to think of the speed of light as merely a number, but perhaps it is something more. Perhaps it is a boundary stitched into the architecture of existence itself. Not a wall built to frustrate us, not a punishment for our curiosity, but a reminder that the universe is under no obligation to behave according to human intuition. And yet, there is something strangely beautiful about that, because every great discovery begins the same way. Someone notices that reality is not what it appears to be. Michelson and Morley discovered an absence. Einstein followed a question, and together they revealed a universe far stranger than anyone had imagined. A universe where distance can shrink, where clocks can disagree, where time itself can bend quietly around motion. But those revelations were still waiting in the distance. For now, humanity stood at the edge of an extraordinary realization. The stars had not become farther away. The universe had not become larger, only stranger. And somewhere ahead, hidden among the consequences of this new understanding, was a truth that would forever change our relationship with time itself. Because once the speed of light enters the story, time no longer belongs equally to everyone. There is a quiet comfort in believing that time belongs to everyone equally. No matter where we are, it seems to move forward with patient consistency. A minute feels like a minute. An hour feels like an hour. Entire lives unfold according to the steady rhythm of clocks that rarely ask us to question them. Time, perhaps more than anything else, feels universal. And yet, the universe has a different perspective. Once Einstein's ideas began to settle into the scientific imagination, physicists found themselves confronting an unsettling possibility. If the speed of light remains unchanged for every observer, then something else must be willing to change in its place. That something, it turns out, is time itself. At first, the effect is almost imperceptible. If you could place a clock aboard an airplane and compare it with one left behind on Earth, you would discover that they no longer agree perfectly. The difference would be extraordinarily small, far too subtle for human senses to notice. But it would be there nonetheless. Two clocks, two journeys, two slightly different experiences of time. It is one of those ideas that feels less like science and more like poetry. The universe does not insist that every traveler share the same passage through time. Instead, it allows each of us to carry our own. As speed increases, this difference becomes more pronounced. Imagine, for a moment, a spacecraft embarking upon a journey to a distant star. At first, nothing appears unusual. The crew moves through familiar routines. Conversations continue. Meals are shared. Days pass, one after another. Inside the ship, life feels perfectly normal. This is an important detail, and one that often surprises people. Time does not feel slower to the traveler. Your heartbeat remains unchanged. Your thoughts arrive at their usual pace. A whispered conversation still takes only a few seconds. If you were aboard such a vessel, you would notice nothing strange at all. The mystery exists only when two journeys are compared. Meanwhile, far away on Earth, something extraordinary would be happening. The faster the ship moves, the more slowly its clocks appear to tick from the perspective of those who remained behind. To the people watching from home, the travelers would seem to drift ever so gently out of sync with the rest of humanity. And the closer the ship comes to the speed of light, the more dramatic this difference becomes. This realization eventually gave rise to one of the most famous thought experiments in all of science: the twin paradox. Imagine two twins. One remains on Earth, living a quiet life beneath familiar skies. The other boards a spacecraft capable of approaching the speed of light and begins a long voyage among the stars. Years pass, or at least years pass for someone. When the traveler finally returns home, the impossible has happened. The twin who stayed behind has grown old. The traveler has not. It sounds like the premise of a novel written beside a fireplace on a winter evening. But it is simply the universe behaving according to its own rules. In a sense, both twins are correct. Each experienced time exactly as they were supposed to. There is no trick, no illusion, no hidden mechanism. Time itself was different for each of them. And while humanity has not yet sent anyone on such a journey, we have observed smaller versions of this phenomenon countless times. Astronauts, for example, are technically time travelers, only by a very small amount. Men and women who have spent months aboard orbiting spacecraft have returned to Earth a tiny fraction of a second younger than they otherwise would have been. Not enough to celebrate a birthday twice, perhaps, but enough to remind us that the universe keeps remarkably precise accounts. Even the technology guiding our daily lives depends upon this strange truth. High above our heads, satellites quietly circle the Earth, carrying clocks of astonishing accuracy. Every day, engineers account for the effects of relativity, because those clocks do not experience time in quite the same way we do on the ground. Without these corrections, systems we rely upon would gradually lose their precision. It is a curious thought. At this very moment, while many people sleep peacefully beneath the night sky, tiny adjustments are being made to machines in orbit because Einstein was right. Time is not absolute. And perhaps the strangest part of all is that we have become so accustomed to this fact that most of us rarely think about it. But let us continue our journey. Imagine our spacecraft once more. Its engines have been burning steadily for years, pushing it ever closer to the cosmic speed limit. Outside the windows, the stars have begun to shift in unfamiliar ways. The crew continues to age normally. 10 years pass aboard the ship. 20, perhaps. Children born during the journey grow into adults. New generations inherit stories of Earth that feel increasingly distant, almost mythical. And yet, when they finally look back toward home, they discover something astonishing. Entire centuries may have passed. Civilizations could rise and fall. Languages could change. Mountains could acquire new names. Everything they once knew might belong to history books. It is difficult to imagine such a separation. Not distance, time. To travel near the speed of light is to make a quiet agreement with the universe. You may continue forward, but you will not do so together. There is something deeply human about this realization. For thousands of years, we dreamed of reaching the stars as though they were simply distant destinations, waiting patiently for our arrival. We imagined grand departures and triumphant homecomings. We rarely considered that the journey itself might alter our relationship with everyone we leave behind. And still, there is beauty in it, because relativity reveals something extraordinary about existence. Time is not a river carrying all things equally. It is more like countless streams flowing side by side, occasionally crossing, occasionally diverging, each traveler moving through their own small corner of eternity. Perhaps that is why the night sky feels both welcoming and melancholic. Every star we see belongs to another time. Even now, while we sit quietly beneath the universe, light from distant worlds continues its endless journey toward us, carrying stories from ages we can scarcely imagine. And somewhere among those distant stars lies a remarkable possibility, that a traveler moving fast enough might witness the future unfolding before them, not through magic, nor through impossible machines, but simply by allowing the universe to keep time in its own way. Because as strange as it may sound, approaching the speed of light does not merely change where you are, it changes when you are. And this was only the beginning. For the deeper humanity looked into the mathematics of relativity, the more another question began to emerge. If time bends, if distances change, if reality itself becomes flexible near the speed of light, then perhaps the universe was not merely asking us to slow down. Perhaps it was trying to tell us that reaching the speed of light would require far more than courage. It would require an impossible amount of energy. By now, the universe has already asked a great deal of us. It has asked us to accept that time is not shared equally. It has asked us to imagine travelers returning home to find centuries waiting for them. And it has quietly transformed light from a simple phenomenon into something closer to a fundamental law of existence. But there is another lesson waiting for us, and this one feels almost personal. Because if humanity has always believed in anything, it is perseverance. When confronted with an ocean, we build ships. When confronted with mountains, we carve roads. When confronted with the sky, we build wings. It is only natural that, upon discovering the speed of light, we would eventually ask a very human question. How much effort would it take to reach it? At first, the answer appears encouraging. If a spacecraft is standing still, a powerful engine can set it in motion. Add more energy, and it moves faster. Add even more, and faster still. This is the world we know. Push harder, go farther, and for a while, the universe seems willing to cooperate. But somewhere along the journey, something changes. Imagine spending years aboard our imaginary vessel, watching the numbers on its instruments climb steadily upward. 10% of the speed of light, 20, 30. The stars outside remain distant, but progress feels tangible. Surely, if we simply continue long enough, the destination will eventually reveal itself. And yet, the closer we come to light itself, the more reality begins to resist. Not suddenly, not dramatically, quietly. Like walking into water that becomes deeper with every step. For many years, physicists described this using the idea of relativistic mass. Objects, they said, seemed to become heavier as they approached the speed of light. The faster they moved, the more difficult it became to accelerate them further. Today, we tend to describe it differently. The mass of the spacecraft remains the same. Instead, the relationship between energy, motion, space, and time becomes increasingly unforgiving. The distinction may seem subtle, but the consequence remains unchanged. Every additional increase in speed demands more energy than the last, and the universe is remarkably strict about its accounting. There is perhaps no equation more famous than the one Einstein left us. E equals mc squared. Even people with little interest in physics recognize it immediately, though few spend much time considering what it truly implies. Hidden within those simple symbols is an extraordinary truth. Mass and energy are not separate things. They are different expressions of the same reality. A tiny amount of matter contains an astonishing amount of energy because the speed of light, the value represented by that small letter c, is unimaginably large. And in a sense, this equation quietly foreshadows the problem we are now facing. The speed of light is not merely fast. It is woven into the mathematics of the universe itself. To approach it is to negotiate with one of nature's deepest laws. Imagine our spacecraft once again. At 50% of the speed of light, its journey is already beyond anything humanity has ever achieved. At 90%, the engineering challenges become almost difficult to describe. At 99%, the numbers begin to feel less like science and more like the dreams of civilizations thousands of years in the future. And still, light remains ahead, always ahead. This is the great frustration of relativistic travel. Each improvement becomes increasingly expensive. To move from 10% to 20% requires energy. To move from 90% to 99% requires vastly more. And to move from 99% to 99.999% demands an amount so enormous that it begins to exceed the imagination. The closer you come to the limit, the farther away it appears, like a horizon that retreats with every step. Eventually, physicists arrived at a remarkable conclusion. No amount of energy is enough. Not because we have failed to invent sufficiently powerful engines, not because we lack determination, but because reaching the speed of light would require infinite energy. And the universe, at least as far as we currently understand it, does not permit infinities to be carried aboard a spacecraft. There is something strangely elegant about this. The ultimate obstacle between ourselves and the stars is not distance, it is arithmetic. Imagine gathering every power plant on Earth, every solar panel quietly absorbing sunlight during the day, every wind turbine turning beneath distant clouds, every reactor, every source of energy our civilization has ever built. Even together, they would amount to very little when compared to what would be required for sustained travel near the speed of light. The numbers become so immense that they lose their meaning. And perhaps that is why discussions about interstellar travel often sound so optimistic at first and so humbling by the end. Because the problem is not building the ship. Humanity is remarkably good at building things. The problem is feeding its hunger. A vessel capable of crossing the stars would consume energy on a scale that makes entire civilizations seem small. And so, little by little, an uncomfortable realization began to emerge. The universe was not merely setting a speed limit. It was enforcing it, not with barriers or walls, but with consequences. Every kilometer per second carries a cost. Every increase in speed demands a greater sacrifice. And somewhere, hidden within this relentless exchange between energy and motion, lies one of the most beautiful truths in modern physics. The universe is consistent. It does not bend its laws for ambition. It does not reward determination with exceptions. A photon and a galaxy alike must obey the same underlying rules. There is, in its own way, a kind of fairness in that. Still, humanity has never been particularly comfortable with limits. History suggests that when confronted with an impossible problem, we tend to stare at it for a very long time. And sometimes, after enough years have passed, impossible things become merely difficult. So perhaps it is not surprising that, after realizing we could never quite reach the speed of light, we asked another question. If we cannot touch the limit, how close can we get? What would the universe look like from the edge of the impossible? And if we spent our lives chasing light itself, what might we see waiting for us there? Because somewhere ahead, our imaginary spacecraft is still accelerating. The stars are beginning to change. The darkness between them is becoming less familiar. And the universe, once again, is preparing to reveal another secret. Let us continue our journey. By now, our spacecraft has traveled farther than any machine humanity has ever built. Earth is no longer a bright world, hanging just beyond a window. It has become a memory, a pale point of light, indistinguishable from countless others scattered across the darkness. And yet, inside the ship, life remains strangely familiar. There are still quiet conversations in dimly lit corridors. There are still moments of silence spent looking through observation windows. Somewhere, perhaps, someone is reading a book, while another traveler sleeps peacefully, gently carried forward by momentum accumulated over many years. It is one of the peculiar gifts of relativity. No matter how extraordinary the journey becomes, it always feels normal to those experiencing it. Outside, however, the universe is beginning to change. Our instruments tell us that we have reached half the speed of light. 50%. Even saying the number aloud feels almost impossible. At this speed, a beam of light leaving Earth would still pull away from us effortlessly. But for the first time in our journey, the difference no longer feels infinite. We have entered a realm where the laws of physics begin to make themselves known in subtle ways. Time aboard the ship is already drifting ever so slightly away from the time experienced by those we left behind. Not dramatically, just enough for the universe to whisper that something has changed. The stars ahead appear a little brighter. Distances, while still enormous, have begun to lose some of their overwhelming scale. The nearest stellar neighbors no longer feel completely unreachable. For the crew, this might be the moment when interstellar travel first feels possible. And perhaps that is what makes the next step so humbling. Years pass. The engines continue their patient work. Eventually, the ship reaches 90% of the speed of light. Now, the universe begins to reveal its stranger side. From the perspective of those aboard, clocks on Earth appear to slow. The outside universe seems to move with increasing urgency, as though history itself has become impatient. Civilizations would rise more quickly. Generations would pass with unsettling speed. The night sky would no longer resemble the one humanity evolved beneath. Something curious happens at these velocities. The stars begin to gather. Not physically, of course, but visually. Light arriving from the direction of travel becomes concentrated, causing the universe ahead to appear brighter and more crowded, while the stars behind gradually fade into darkness. It would feel as though the cosmos itself were leaning toward the ship. Imagine standing before a great river and watching all of its currents slowly converge toward a single point on the horizon. That is what the heavens would begin to resemble. And still, our journey continues. 95%. 99%. By now, time has become deeply personal. A decade aboard the ship could correspond to many decades elsewhere. Children born during the voyage might inherit a future that no longer remembers the world of their ancestors. The distance to distant stars continues to shrink, not because space itself has changed, but because the traveler experiences it differently. This is one of the most extraordinary consequences of relativity. At sufficiently high speeds, the universe in front of you contracts. A destination that once seemed impossibly far away begins to draw nearer. Not for those waiting at home, only for the traveler. It is almost as though the cosmos takes pity on those willing to chase its horizon. And then, at last, we arrive at a number that would have sounded like pure fantasy to every generation that came before us. 99.9999% of the speed of light. Our instruments can barely distinguish the difference between our velocity and the great cosmic limit itself. Surely, one might think, we must have nearly arrived, but the universe remains unmoved. Light still travels faster. It always does. No matter how many nines we add, there is always room for one more. There is something strangely poetic about this. Humanity has spent thousands of years chasing distant lights across the sky, only to discover that the fastest thing in existence remains forever just beyond our reach. And yet, the universe has one final surprise waiting for those who dare approach its limits. The sky itself begins to transform. The familiar colors of stars drift toward blue and violet as their light is compressed by our motion. This phenomenon, known as the Doppler effect, is something we encounter in everyday life whenever a passing siren changes pitch as it moves by. But here, among the stars, the effect becomes almost unimaginable. Entire regions of the sky shift in color. Invisible wavelengths are pushed into visibility. The darkness ahead becomes flooded with unfamiliar light. For the crew of our ship, the universe would no longer resemble the one described in ancient stories. It would become something entirely new, something no human eyes were ever meant to see. And then another problem emerges, a dangerous one. Space, as it turns out, is not empty. It only appears that way. Between the stars drift lonely atoms, most of them simple hydrogen that has wandered through the galaxy for millions of years. At ordinary speeds, they are harmless. At velocities approaching the speed of light, they become something else entirely. Projectiles. Each tiny atom strikes with extraordinary energy, carrying enough force to threaten the integrity of the spacecraft itself. The emptiness between stars becomes an ocean filled with invisible rain. Even light, which once guided us, begins to present challenges. Radiation from distant sources grows increasingly energetic as it shifts toward shorter wavelengths. The universe ahead brightens and becomes more dangerous. It is a remarkable realization. For centuries, humanity imagined the space between stars as a vast and peaceful emptiness. But at the edge of the possible, even emptiness refuses to remain empty. There is a certain melancholy in all of this. The faster we travel, the stranger reality becomes. Distances shrink, time slows, stars gather, colors change. The darkness itself acquires teeth, and still, light remains ahead, moving with effortless certainty, indifferent to our pursuit. Perhaps this is the universe's gentlest lesson, that some boundaries are not meant to frustrate us. They are meant to reveal us, because there is something profoundly human about continuing the journey, even after discovering that the destination cannot be reached. And somewhere in the quiet hum of our imaginary spacecraft, as generations look out upon a sky transformed beyond recognition, another question begins to emerge. If the universe will not allow us to outrun light, could we, perhaps, find another way? Could space itself carry us where speed cannot? For if humanity has learned anything from its long history beneath the stars, it is this: when a door remains closed long enough, eventually, someone begins looking for a different path. Humanity has always had a complicated relationship with impossibility. Again and again, history has introduced us to limits that seemed absolute. There was a time when crossing an ocean felt unimaginable, a time when leaving Earth itself belonged entirely to the realm of dreams. And so, perhaps it is only natural that, after discovering the universe's great speed limit, we began searching for loopholes. Not because we refuse to accept reality, but because curiosity rarely sits quietly for very long. Somewhere, at this very moment, there are scientists filling chalkboards with equations, engineers imagining technologies centuries beyond our reach, and writers giving shape to futures that may never arrive. All of them, in one way or another, are asking the same question. If we cannot move faster than light, could space itself do the moving for us? It is a wonderfully human idea. Rather than outrunning the universe, perhaps we might persuade it to carry us. This thought has appeared in countless stories over the years. Entire generations have grown up hearing about ships that leap effortlessly between stars, disappearing from one corner of the galaxy only to emerge moments later in another. Science fiction has always had a habit of visiting impossible places long before science itself. And occasionally, if history is kind, reality follows. One of the most famous examples is the concept of a warp drive. The name alone feels as though it belongs beside the stars. The basic idea is surprisingly elegant. According to Einstein's relativity, nothing can travel through space faster than light. But relativity says something very interesting about space itself. It can expand. It can stretch. The universe has been doing precisely that for billions of years. Distant galaxies are not racing through an unchanging cosmos. Rather, the space between them is growing. And so, a remarkable question emerged. What if a spacecraft never exceeded the speed of light locally? What if, instead, it compressed space in front of itself and expanded space behind it? In this scenario, the ship would remain comfortably at rest within its own small bubble, while space-time carried it across unimaginable distances. It sounds less like engineering and more like a dream whispered between astronomers late at night. Yet, the mathematics, at least in principle, does not entirely forbid it. There is, however, a complication. There always seems to be. To create such a distortion in space-time, our equations suggest we would require something exotic. Forms of matter or energy unlike anything we have ever observed in usable quantities. Negative energy. Exotic matter. Terms that sound as though they belong in ancient myths rather than scientific journals. And despite decades of investigation, the universe has remained characteristically quiet on the subject. Still, the idea persists, because even an unanswered question possesses a certain beauty. Then there are wormholes. If warp drives are humanity's attempt to persuade space to move us, wormholes are our attempt to fold space entirely. Imagine drawing 2 points on a sheet of paper. Under ordinary circumstances, the shortest path between them is a straight line across the surface. But if you gently fold the paper until those 2 points touch, the journey becomes almost instantaneous. That, in essence, is the dream of a wormhole. Not traveling faster, simply traveling differently. The mathematics of general relativity permits solutions that resemble these cosmic shortcuts, though whether nature allows them to exist in reality remains one of the great unanswered questions of modern physics. If wormholes do exist, they may be fleeting, unstable, or hidden in places we have yet to discover. Or perhaps the universe simply prefers its distances to remain intact. There is a quiet humility in admitting that we do not know. After all, the history of science is filled with moments when certainty gave way to surprise. No one expected time to slow. No one expected space to bend. No one expected light to become the storyteller of the cosmos. Who can say which mysteries remain patiently waiting among the stars? And perhaps there is another possibility, one that receives less attention, but may prove far more realistic. What if humanity never travels to the stars in person? It is a thought that feels strangely bittersweet. Perhaps we will send machines instead, silent explorers carrying the accumulated knowledge of an entire species. They would not grow tired. They would not fear the passage of centuries. They would simply continue onward, faithfully crossing the darkness long after Earth itself has changed. Or perhaps we will send something even more intimate, our descendants. Not children in the traditional sense, but generations born aboard vast interstellar vessels, entire civilizations living and dying between stars, each inheriting a journey begun by ancestors they would never meet. To them, the ship would not be transportation, it would be home. And then there is another possibility still. Perhaps consciousness itself will travel. Future technologies, if they ever come to exist, may allow us to preserve minds in forms we cannot presently imagine. A civilization made not of flesh and bone, but of information, moving patiently across the galaxy at speeds that no longer concern it. These ideas remain speculative, of course. The universe has not yet revealed which paths, if any, it intends to leave open. But there is a question worth considering on quiet nights such as this. What if we had been asking the wrong question all along? For centuries, we have asked, how do we travel faster than light? Perhaps the better question is, how does the universe allow journeys to happen at all? Because the deeper we look, the more it seems that nature is not interested in denying us wonder. It merely asks that we earn it. And maybe that has always been the point. After all, every star humanity has ever studied, every planet ever discovered, every galaxy ever photographed, has reached us without moving an inch. Their light made the journey on their behalf, patiently, faithfully, across billions of years. There is something comforting in that thought. The universe does not appear to be in a hurry. It is content to let stars live for billions of years, and galaxies drift apart over unimaginable spans of time. Against such a backdrop, perhaps our impatience says more about us than it does about the cosmos. And yet, despite everything we have learned tonight, despite relativity, despite infinite energy, despite the impossible distance separating one star from another, I suspect humanity will continue looking upward. We always have. There will always be someone standing beneath a quiet sky, wondering whether another path exists. And perhaps that is enough. Because curiosity, unlike spacecraft, has never required fuel. It crosses every boundary we have ever encountered. And as our journey through the night slowly approaches its end, one final question remains. What does this great cosmic limit actually tell us about the universe itself? Why would reality be built this way? Why would a cosmos so vast allow us to see distant stars while placing them forever beyond easy reach? The answer, if there is one, may be less about physics and more about perspective. And so, after traveling farther than any human being ever has, through thought experiments, through equations, through centuries of discovery, we find ourselves in a familiar place once again. Beneath the night sky. It is strange, isn't it? We began this journey asking a simple question. Why won't the universe let us reach the speed of light? Along the way, we discovered that light is not merely something that illuminates the cosmos. It is woven into its foundations. It measures distance. It shapes time. It quietly determines what is possible and what remains forever beyond our grasp. And perhaps, more importantly, it reminds us that the universe is under no obligation to be simple. There is a temptation, when speaking about the speed of light, to think of it as a barrier, a great cosmic wall standing between ourselves and the stars. But tonight, after everything we have seen, I wonder if that is the right way to think about it at all. After all, barriers are usually built to keep things apart. The speed of light has done precisely the opposite. It is the reason we know the stars exist. Every galaxy humanity has ever photographed arrived here on a beam of light. Every sunrise, every eclipse, every image returned by a telescope orbiting quietly above our world. Even now, as these words accompany you through the night, light is continuing its endless work, leaving distant suns, crossing silent nebulae, passing through the spaces between galaxies, traveling faithfully onward without ever becoming lost. Perhaps the speed of light is not the universe saying, "You may go no farther." Perhaps it is the universe saying, "This is how my story is told." There is a certain humility in realizing that. For thousands of years, humanity has measured its progress by the limits it has overcome. We crossed seas, climbed mountains, reached the moon, and placed our machines among the planets. And yet, some limits remain. Not because we are incapable, not because we lack imagination, but because reality itself is built upon them. The older I imagine our species becoming, the more I suspect we will eventually make peace with this. One day, perhaps centuries from now, our descendants may travel between stars in ways we cannot yet imagine. They may carry with them the accumulated memories of Earth, preserving the stories of oceans, forests, and the countless generations that once looked upward with hope. Or perhaps they will discover that the universe was never asking them to move faster, only farther, patiently, one journey at a time. Because the truth is that humanity has already accomplished something extraordinary. Against impossible odds, on a small world orbiting an ordinary star, the universe became aware of itself. That may be the greatest miracle of all. Atoms forged inside ancient stars gathered together and, over billions of years, learned to ask questions, learned to wonder, learned to dream about places they would never see. And somewhere along the way, they gave themselves names. They called themselves human. There is a beautiful irony in this. The same universe that prevents us from reaching the speed of light also allows us to understand what the speed of light is. It allows us to measure distant galaxies, to predict eclipses centuries in advance, to imagine voyages that may never happen, and to sit quietly beneath the stars, listening to stories carried across time itself. Perhaps that is enough, or perhaps it always was. If there is a lesson hidden within this great cosmic limit, it may simply be this: the universe is not a puzzle to be conquered. It is a companion to be understood. And companions do not reveal themselves all at once. They speak slowly, over billions of years. Tonight, as our journey comes to an end, the stars continue shining above us, exactly as they did for those who came before. Somewhere, a distant sun is setting on a world we will never know. Somewhere else, light has only just begun a journey that will outlast mountains, civilizations, and perhaps even our species itself. And still, it travels, patiently, quietly, without ever asking for anything in return. There is comfort in that, because no matter how vast the universe becomes, no matter how many mysteries remain waiting beyond the darkness, one small truth endures. You are part of this story. You always have been. The atoms within you were born in stars. The light reaching your eyes tonight has crossed impossible distances to find you. And for a brief moment, in a universe nearly 14 billion years old, you were here to witness it. Perhaps that is what the speed of light has been trying to tell us all along. Not that we are small, but that we are connected. And maybe, just maybe, that is why the universe never needed to let us catch the light. It only needed to make sure the light could always find us. So wherever you are tonight, as the world grows quieter and the stars continue their patient work overhead, you can rest knowing that the universe is still telling its story. It has been telling it for billions of years, and this evening, for a little while, it shared a small part of that story with you. Good night, and may the light always find its way home.